In this video, we're going to look at exact values of circular functions. And you need to know the values for 0 radians or 0 degrees, pi on 6 radians or 30 degrees, 45 degrees, pi on 4, 60, pi on 3, and 90 and pi on 2. So you need to know all of those values. You need to know all of those values off by heart because you can be asked questions about that in the calculator-free exam. And you won't have your reference book with you or your bound book with you, so you need to know those off by heart. So there are some strategies that you can use to remember the exact values, and I'm going to go through them in the order that they appear here. So first, look at the 2 reference angles. These are only good for 3 out of the 5 angles that you need to remember. We'll look at the unit circle definitions with small, medium and large values for sine, cos and tan, and how that includes all the angles. We'll look at the table of values and use patterns to help us remember the table of values. And then finally, I'll show you the hand trick, which is my own students' favourite. So these are the 2 reference angles where you first generate exact values for pi on 3, pi on 4, and pi on 6. And so I'm not going to show you the derivation of where these come from, but lots of people like to draw these and then use their Year 9 trig ratios to find sine, cos and tan for these using SOHCAHTOA. So for pi on 4, sine of the angle is opposite over hypotenuse, 1 on root 2. Cos of the angle is adjacent over hypotenuse, 1 on root 2. And tan of pi on 4 is opposite over adjacent, so tan is 1. The same here for pi on 3, opposite over hypotenuse will give you sine, adjacent over hypotenuse will give you cos, etc., etc. Let's look at the next one that includes that uses the unit circle to bring in our 0 and pi on 2 degrees. So this is the first quadrant of the unit circle. And I have my angles pi on 6, pi on 4, pi on 3. Pi on 2 is up here, and this point here on the unit circle has the coordinates of 0 and 1. And for this to work, we need to remember that the coordinates of each of these points, so the x value is the cos value, and the y value is the sine value. So you can see I've labelled the y-axis as sine theta, and the cos and the x-axis as cos theta. So our angles are small, pi on 6, medium, pi on 4, and large, pi on 3. And so our sine, cos, and cos values, you can see I've got a list here. So you can either write them in this way or in their equivalent with the square roots all on the top. So the square root of 1, square root of 2, square root of 3. Some people like to write it like that. So I label these as small value, medium value and large value, and they sit on the axes as small, medium and large for cos, and small, medium and large for sine. And so if you can figure out whether the angle that you're working with is the small, medium or large angle, you can visualise this quadrant in your head. The small angle is going to have the large cos value, which is root 3 on 2, and it's going to have the small sine value, which is a half. For the tan values, you also have just 3 values realistically. More than 3 values, well, yeah, anyway, you've got 3 values that you need to remember here as well as 0, and they are in order. So the numbers all include either 1 or root 3 or a combination of the 2. And so the smallest is 1 on root 3, 1 and root 3. And the thing that I like about this particular way of remembering is for tan, you measure for tan from the point where it touches the unit circle through the origin of the circle, and you extend that line to where it cuts the tangent line and you read it off here. So tan of 0 degrees is 0. If I head round to pi on 2 and I make a line that goes between the the origin and pi on 2, and then I extend it in any direction until it cuts the tangent line, you can see that this line is actually parallel to this line. This is the line x is equal to 0, and our tangent line is the line x is equal to 1. They're parallel, so they're never going to cross, and so the answer is undefined. So this next option, the table of values, combines all of the values from the unit circle all into a table. And there's lots of patterns in here, and people that use the table remember it by the patterns that it goes with. So let's have a look over here at, I filled this one in with some radians at the top. So it goes 6, 4, 3, 2, so that's going down, and then these numbers in here, you'll notice that all of the sine and all of the cos are all over 2. They're all the square root of something, and the numbers go starting from this end, so these numbers go down and the numerators go down this way, 4, 3, 2, 1 and 0, and then they go down. If you pop down to here, then the numbers go down again, 4, 3, 2, 1 and 0. And then you need to go through and simplify those, which I'll do for you now. And there are the simplifications there. Now to work out tan, you can either remember the numbers or you can remember that tan is sine theta divided by cos theta. And sine theta divided by cos theta, or sine over cos, can be written as sine theta divided by cos theta. And so what you can do, let me just make this a little bit bigger here, is you take your sine value and you divide it by your cos value, which is what I've done here. Sine value divided by cos value. When you divide by a fraction, you change the divide to a times and you flip this end one. Then you'll get your, maybe, your 2's to cancel, and you'll end up with 0 over 2 root 4, which is just 0, so a 0 goes in there. We'll do it once more with this angle here. So sine divided by cos, change it to multiply and flip. The 2's will cancel, and you're left with the square root of 1 over the square root of 3, which is 1 over root 3, 1 over root 3. And if you go through and do the rest, so root 2 on 2 divided by root 2 on 2, that's 1. If you do root 3 on 2 divided by root 1 on 2, the 2's will cancel and you'll end up with root 3 over root 1, which is just root 3. And for the last one, 1 divided by 0, undefined. So you can just remember that table. And finally, the hand trick. As I said, this is my students' favourite one. So you can put your hand out facing you and you label your fingers like the lines that I had on the unit circle. So this is 0 degrees, if you like, the x-axis. This is 90 degrees, your y-axis. And this finger represents pi on 6, this finger represents pi on 4, and this finger represents pi on 3. And that's the only association it has with the unit circle. And so the rules that we use for finding cos and sine and tan are these formulas here, where we talk about the square root of the number of top fingers, the square root of the number of bottom fingers, and then for tan we turn our hand over and we do the square root of the top fingers divided by the square root of the bottom fingers. You're probably thinking, what on earth? So let's have a look. So here we have a hand with the pi on 3 finger folded down. You can see above there's one finger, thumb is classified as a finger, and below there are 3 fingers below. So for cos, you count the number of fingers above. So my kids say cos to the clouds up above. And so there is one finger up above. And so cos of pi on 3, the square root of 1 is 1 over 2. Cos of pi on 3 is a half. For sine value, you need to count the number of fingers below. There are 3 fingers below. So we put a 3 in the square root. So sine of pi on 3 is root 3 on 2. To find tan, you flip your hand over, and now we've got 3 fingers on top of the finger that's folded down and 1 finger on the bottom. And for our tan value, our numbers from our fingers go top fingers at the top, bottom fingers at the bottom. So tan of pi on 3 is root 3 over 1, which is root 3. But what do you do if you have no fingers below? So say we're working with 0 degrees or 0 radians. It doesn't matter, same deal. We've got 4 fingers up above, 1, 2, 3, 4. And so our cos value, number of fingers to the clouds, is 4 for cos and 0 for sine. And so our cos value, the square root of 4 is 2 over 2, which is 1. And our sine value, the square root of 0 is 0 over 2. 0 divided by any number is 0. To find tan, you turn your hand over. And now we've got our 0 degrees here, and we've got no fingers at the top, no fingers here, and we've got 4 fingers at the bottom. So it's 0 over 4. Which is 0 divided by 4. Anything 0 divided by any number is 0. Now it's your turn. So let's do pi on 2. Put your hand in front of you, whichever hand you're not writing with. Use the hand that you're not writing with so that you don't have to put your pen down to do this. Okay, so fold your thumb down, and sine and cos are flipped around. So remember, cos is to the clouds, so that's the one at the top, and it works whether you're left-handed or right-handed. And have a go. I'll put the answers in a sec. Okay, how'd you go? You should have got 4 fingers on the top for sine, on the bottom for sine, 0 fingers on the top for cos. That makes sine of pi on 2 equal to 1 and cos of pi on 2 equal to 0. If you flipped your hand over, you should have got square root of 4 over square root of 0, which gives us 2 over 0. And any number that you try and divide by 0, you get an undefined answer. So in summary, to use the hand method or the hand trick, you need to know cos is the top fingers, sine is the bottom fingers, and you flip your hand over for tan. You can still use sine divided by cos to work out your value for tan.